Okay, so welcome back. In this video, we are going to talk about how we can prove that there does not exist non-zero integers. For instance, a and b such that a squared is equal to 3b squared. This proof, we are going to go by proof by contradiction, okay? Just like when you have square root of 2, and you're asked to prove that this is an irrational number, okay, there is no way or there is no other way to go and prove this than to prove by contradiction, by saying that square root of 2 is a rational number, where in your mind you know that square root of 2 is not a rational number. So you just assume that square root of 2 is a rational number, then you prove by contradiction. Then at the end, you tell them that through this process, we can see that our initial assumption is false. Then you conclude, that's all. So this proof normally goes with proof by contradiction. Okay, so let's dive into it. So to prove that there does not exist non-zero integers a and b such that a squared is equal to 3b squared. First, we have to assume that this here is false. Okay, so we have to assume that there exists non-zero integers. Okay, there exists non-zero integers a and b such that a squared is equal to 3b squared. Okay, so this assumption is basically telling us that this equation a squared equals 3b squared is suggesting that a squared is divisible by 3. Okay, so meaning that a itself must be divisible by 3. Okay, so that is the meaning of this whole assumption. Okay, so if a squared is divisible by 3, it means that a is also divisible by 3. So we continue from here, where we know that since a is a square, okay, is divisible by a prime okay, a prime number, only if the original number is also divisible by 3 as well. So since a is divisible by 3, then we can write this a as a is equal to 3k, okay, where k is any integer, okay, any positive integer, okay, where k is for any integer, okay. So if a is equal to 3k, then let's name the main equation as equation 1 and name this as equation 2. So we put 2 into 1, then we're going to have a is equal to 3k, so we substitute here and we're going to have 3k all squared is equal to 3b squared, right? So this we're going to have 9k squared is equal to 3b squared. So this we can see that we're going to have 3k squared is equal to b squared, right? So since b is divisible by 3, it means that b squared is also divisible by 3. So this means that this statement over here, let's name this equation 2. So once we have b squared here, it means that b is divisible by 3 and b squared is also divisible by 3. So that is, we can also assume another integer, okay, m. Okay, so let's say that b is equal to 3m. Okay, so let's say that b is equal to 3m. Okay, because b is divisible by 3, so it means that for sure b squared will also be divisible by 3. So we're going to have, when you do this, right, put 3 into 2, we're going to have 3k squared is equal to 3m all squared. Okay, so we're going to have 3k squared is equal to 9m squared. Okay, so this we have here is meaning that k squared is equal to 3m squared. And this, you can go and go and go and go and go. So this means that k squared is equal to 3m squared, meaning m is divisible by 3 and m squared is as well divisible by 3. So thus k is also divisible by 3. Okay, so that's k is also divisible by 3. Okay, so we have this here. So this proof, okay, you can go and go and go and go and go because it's going to be infinitely decent, because there is no way you have a non-zero integer. We have shown that if a and b are divisible by 3, okay, then by this equation, okay, given this equation, then it means that we can divide a and b many times, many times. So repeating this argument indefinitely many times, it will imply that a and b, a squared is equal to 3b squared, does not exist non-zero integers, right? So hence, with this argument, we can say that we have proven that there does not exist non-zero integers a and b such that a squared is equal to 3b squared. Okay, so this will contradict our initial assumption that there exist non-zero integers such that a squared is equal to 3b squared. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mate, and I'll give you more updates. Bye bye.